Let's take a look at this next question. For the same chipmunks above, so these are the chipmunks with nub or no nub condition, a second gene determines fur pattern. Big B is horizontal bars and little b is no bars. Big B is completely dominant over little b. And this second gene is found on the X chromosome. There is no corresponding gene on the Y chromosome. Now this is very important information because this is telling us that this trait is sex-linked. And so we have to treat it somewhat differently than we would the other conditions. So let's take a look at our question. A male chipmunk, nub, no bars, mates with a female chipmunk, nub, barred, that is a heterozygote for that barred. What will be the expected phenotypes and probabilities of their offspring? Give the fractions and of the total living offspring for every combination of the nub, the sex, and the bar. So there's two ways to approach this problem. One of them is to make a really big expanded Punnett square like you saw in one of the previous videos. The other one is to make Punnett squares individually for each trait, figure out the probabilities for that particular trait, and then put together and combine all of your knowledge from the different Punnett squares to figure out the overall probabilities. Now you're going to get the same answer regardless of which route you take. Some people just like doing one of them over the other. Pick the approach that works best for you and that you like the most. For me, it is to split it up into different Punnett squares, so that's what I'm going to show you here. So we're going to have a male chipmunk that is going to be nub, so we know that he's going to be big C, little c, and he's going to have no bars. Because he is male, we know that he's going to have one X chromosome and one Y chromosome. And because he has no bars, he must be recessive for that particular allele, for that trait. Now the female is also going to be nub, so big C, little c. She is female, so she's going to be XX, and the question tells us that she is a heterozygote. So we're going to use B's to refer to that bar versus no bar condition. So let's first take a look at the nub versus no nub condition and what the probabilities are that we could get from there. And we've done this Punnett square before, so this should not look new to you. We can make our Punnett square and we can figure out what our probabilities of our different phenotypes and genotypes are. Now in this condition, if you remember, the big C combination was a lethal combination. And so what we end up with is 2/3 of the individuals are going to have a nub tail. You can see there 1, 2, that's nub. And 1/3 is going to have the normal condition. Okay, 1 out of the 3 right there. Now let's take a look at our Punnett square for the bar versus the no bar condition. Here we know that the female is going to give us this alleles, can contribute either of those two alleles, and the male can contribute either of these. And so we can create our Punnett square here and fill it in just like we would with any of the other examples. So what you can see here is that you're going to end up with a female who is barred. So female and bar 1/4 of the time. And you're going to get female with no bar 1/4 of the time. You're going to have male with bar at a ratio of 1/4 and male with no bar at a ratio of 1/4. Now we can put together the information that we have from both of our Punnett squares to figure out what all of the conditions might be. So we might have a female who is bar and nub. Okay? And so for that, our ratio is 1/4 times having a nub, which is 2/3. And so we are going to end up with 2/12. Okay? We can have a female who is a bar and normal, which would be at a rate of 1/4 times 1/3, which would be 1/12. We can also have a female that is no bar and nub, which would be 1/4 times 2/3, or 2/12. Or we can have a female who is no bar and normal at, whoops, you can't really see that well. Let's see if we can move that. We'll write it here again. A female with no bar who is normal. And that's going to be 1/4 times the normal condition, which is 1/3, and is going to be 1/12. So there are basically 4 possibilities of females that have bars or no bars and either nub or normal tails. Now we have to do the same thing with the males. We can have a male who is no bar and normal, and that's going to be 1/4 times 1/3, which is 1/12. You can have a male, no bar, and nub, which is going to be 1/4 times 2/3, or 2/12. You can have a male who has bar and normal. That's going to be 1/4 times 1/3, or 1/12. And finally, you could have a male who has bar and nub, which is 1/4 times 2/3, or 2/12. So all of these that you see here and here are the probabilities and the lists of all of the potential offspring when we look at the nub condition, bars versus no bars, and sex.